Okay, so it wants us to integrate 4v times the square root of v plus 2 dv. So what I like to do is I take the most complicated part of this expression and let that be u. So in this case, this v plus 2 is going to be equal to u. And then ideally we want to find the derivative of u somewhere in the integral, so I can replace that with something involving the derivative of this. So if I differentiate both sides, I'm just left with dv equals du. So I can replace dv with du. I can replace v plus 2 with u, but I still have to replace this v with something, this 4v. So that's where the hint comes into play. The hint basically says that if I have this, I can write v as u minus 2 if I subtract 2 from both sides. So now I can replace v here with u minus 2. So this whole integral becomes 4 times, instead of v, it's going to be u minus 2, square root of u, we'll just say it's u to the 1/2 times du. So now I've just written everything in terms of u instead of v. So now this looks uglier, but it's actually going to be nicer once we multiply everything out. I can distribute the 4 and distribute the u to the 1/2. So this first term is going to be 4 times u to the 1/2. So this is 4 u to the 3/2. 4 times negative 2 times u to the 1/2 is negative 8 u to the 1/2 du. Now I can integrate this. So I add 1 to the exponent, I get u to the 5/2. I get 2/5 times 4 u to the 5/2 minus, this is going to be 3/2, so this is 2/3 times 8 u to the 3/2 plus c. Cleaning this up a little bit, we have 8/5 u to the 5/2 minus 16/3 u to the 3/2 plus c. And now we can go back and replace u with what it originally was, which is v plus 2. So this is going to leave us with 8/5 v plus 2 to the 5/2 minus 16/3 v plus 2 to the 3/2 plus c.